All right, guys. So as I was saying before, we were just interrupted. So as I was saying here is that when we look at this expression here, what you notice about this expression is that each term within the expression has a different variable or a different unknown. And this term is the product of a squared times b. The variable here is a squared times b. The variable in this one is a b cubed. This one is a squared b squared. The fact that these are all different terms, or in other words, all different variables, or it means that this is a product of unknowns. For each of them, the product of the various unknowns, they are all different. And because they're all different, that means they become unlike terms. Now, if they have the same product, same power, then in that case, you would treat them as like term. Because, well, not treat them as like term, they would be like term in that case. All right, so when unlike terms are added, they form expressions and cannot be simplified any further. So that's something that you should know. So once you have unlike terms and you're adding them and subtracting them, you leave them with the plus and minus sign between them as the final answer. You can't simplify them anymore, so you leave them as an expression. All right. Now, one other thing to point out, guys, expressions by themselves don't carry equal sign. So notice that there is no equal sign with this. So when we're referring to expression, we're just talking about the unlike terms that are added together, right? Now, there are times, however, when we may form equations, but once we have equal sign in the mix with expressions or numbers or so on, then it becomes an equation. Now, the left-hand side here is an expression. But this expression can be simplified because this expression have like terms. So this is an expression with like terms. And so you have to understand that expression doesn't mean that you only have unlike terms in expression. Sometimes you have like terms in expression. Is that clear, guys? So you may have an expression with like terms, or you may have an expression with unlike terms. The expression with like terms, you can simplify them by adding the coefficients. And then now it would be simplified into a single term. But for unknown, when you add those in expression, you can simplify them to a single term. So you leave them as is in the expression. So here, this expression, which is 7x minus 5x plus 3, is an expression. And remember, expression has what? Plus or minus signs between them. All right, so all the terms in this expression are like terms. And in order to add them, we simply do what? Add their coefficient. Now, one of the ways that you could write this when you're adding, you could put all the coefficients in brackets. So you put the 7, you put the -5, you put the +3, put all the coefficients in brackets. Now, because the variables are the same, and in other words, the variable would be common. So if you put the variable outside there, and then focus on adding what you have in the brackets, then you would add these just as integers. So you have $7, or if you have 7 minus 5, that becomes what? Anybody?
2, sir.
Right, and then you add 3, you get what?
5.
Right, so all of this would simplify to 5. And then now you would just write back the variable beside it. Any question? Let me see the hands of those who clear on what I'm saying. All right, good. Now, this is another case where we have these are like terms in this expression. And for this expression, once the terms are like terms, we just add the like terms together by adding their coefficient. Miss McIntosh, you want to say something? See your hand still raised.
No, sir.
Okay. All right, so once you can identify that the coefficients, not the coefficient, the variables are the same, you just simply add the coefficients. So 3 plus 7 give you 10. And you put back the variable beside it. All right, now, I know that some students will probably make the mistake by saying if you add b squared plus b squared, you get b to the 4th. Please don't do that, students. You're not changing the power of the variable. You're not changing the variable itself. Whatever the variable is in the expression is the same variable you must have in the result. Is that clear? Everybody? All right. I don't hear anybody responding. So
Yes, sir.
I'll take it that your silence is. All right. So here now, you notice that all we are focusing on when we are adding is the coefficient. Once the variables are the same, we just add the coefficient. So this is a -3 plus a -5. We get a -8. All right, everybody should be comfortable with adding integers by now. Now, remember we say that when there's no obvious number in front of the letter, or in other words, there's no obvious number in front of the variable, then the coefficient would be what? 1. So even if it is not there, you should remember that there's an invisible 1 there. So this would be 1q minus 3q. So you would now have a +1 and a -3. Take away 1 from 3 and keep the sign of the larger one. It becomes -2q. Everybody should be good with all of what I've explained. Now here we have an expression. Within this expression, though, we have a number of terms. Group of them are alike. And so what we want to do when we're simplifying such expression, we want to group the like terms together The ones that have the same variables, we group them together. So here we would group the 8x. We group that with the minus 5x. And you can just do the grouping just for simplicity. When you become a little bit more proficient, you probably can simplify it without doing the grouping. But for now, just practice to group them so that you don't make mistakes. So now you group the 3y. And you have another y over here, which is 2y. Now, don't overlook their sign, students. So this is a negative 2y, so you bring negative 2y here. All right, so whatever sign they have, you carry the sign with them. And the sign is always in front of the terms. All right, so we group this 3y with this negative 2y. Now we have z's. So we're going to group those two as well. Now, so we have negative 4z, z for some people, plus 7z, plus 2z. Now, once you group them, now you can see more clearly the terms that you're adding. So you're adding like terms. So these are like terms. You add those together. You add those together. And all of these you add together. So now you have 8 minus 5 for the x. So this will give you what? 3x. When you simplify the like terms of the x. Now here you have what? 3 minus 2 for the y. And 3 minus 2 give you 1. And so we're not going to write 1y. It's a little bit, it's mathematically, we say it's mathematically naive when you write 1y. Because as a mathematician, we know that there's an invisible one there, so we're just going to write y. All right? So that would give you y, if you're adding 3y and then you're minus 2y, you have 1y, which we just write as y. Over here for the z's now. I know sometimes my 2's look a little bit like z. Please don't. So oftentimes I will put a little stroke here to differentiate my z's. But sometimes they really look like a 2. All right, so we have minus 4z plus 7z. And then we have plus 2z. Now remember, you are dealing with positive and negative numbers. So we're just focusing on the coefficients. So we know that positives are what you have. So you add them together. So 7 plus 2 give you positive 9. You know that negative is what you owe. So you would pay out from what you have. So if you have 9 and you give back 4, then you're only going to have 5 remain. So now this would leave you with positive 5z. Now, once we have simplified here, I will simplify each group of like terms. What we have left as our answer is an expression with now 3 unlike terms. And because we can't add them together by adding their coefficients, then this remains as an expression. So for this one, the answer will be 3x plus y plus 5z. Now, oftentimes when we are adding terms, one of the things that we like to do in mathematics is to write these terms in a particular order. And the order that we choose to write them in is the order in which they come in the alphabet. So we write the X first, the Y second, and the Z. Because the X come before the Y come before the Z, and so on. So we write them in that order. Now, if it is that you write the Z first, then the X, then the Y, it doesn't mean that your answer is wrong. It only means that you don't write it in the order that we would like you to write it in, but the answer is still correct. But as a practice, we generally write them in the order in which they come in the alphabet. So anything that we do as a practice in math, we call it a convention. So because we practice to write our letters in this way, then we call that a convention. So the conventional practice here is to write these unknowns in the same order that they would come in the alphabet. All right, is that clear to everybody? Let me see your hands. Anybody is still not clear on, anybody who is not clear and you want some clarification, you can.
Sir, how you get the 5 for number 5?
Or you get the 5. So for number 5, sorry, I said, how we get the 5. So we get the 5 because we are dealing, is it 5 though? Maybe that's a good question. 2 from 7 leave 5. Oh, we get 5. All right, so we have 7 and 2. These are the positive, right? So when you add the positives, you get what? Positive 9. You agree? Follow?
Yes, sir.
And so this becomes 9Z. Now this one is a negative. So it means that we are going to subtract. So if you have 9Z and you take away 4Z, then you are left with 5Z. You follow?
Yes.
Right. So when you're adding them, you're not just adding them based on the coefficient. No, you have to pay attention to the sign that is in front of them. So the sign that is in front of them tell you whether or not they're positive or negative. And so you know that when you're dealing with integers, you have to add them based on the sign, right? So all the rules that you would have learned when you're dealing with integers, you have to apply them when you're simplifying algebra. All right, so I hope that is clear for everybody. So we want to move on now to the next part. All right, so here, this is the fun part now. So now you get a chance to simplify the following. So you're going to, these are pretty easy and straightforward, I would assume. But sometimes they say, was it Frog who said that what is joke to you is dead to me? So I won't take it for granted that because it might be simple for me, it is simple for others. And that's why we practice, because we practice to develop the skills of being able to do these. All right, so I'm going to give you at least, so we have 10 questions. So I'm going to give you 5 minutes. So each question should take you at least 2 minutes to do. So 5 minutes to do all 10 questions. And then now, when you're finished, we're going to walk through the questions. All right, so be prepared to walk me through a particular question with your answer. All right, guys? So your 5 minutes begins now. My apology, guys. I said that I would give you at least 2 minutes to do one question, and I gave you 5 minutes. All right, so I'm going to give you at least 10 minutes to complete all of them. All right, I think that's a little bit more realistic. All right, so in the meantime, while some of you still are working on the question, is there anybody who finished with the first couple of questions and would like to walk me through them? For question 1, can anybody give me the answer?
Sorry, 18x.
All right, so this will be 18x. All right, I'm going to try and give each person a chance to answer one of these. So anybody else apart from Miss Scott want to give me the answer to the next one?
Yes, sir. 2x.
All right, so that's 2x. Anybody else for the next one?
Yes, sir. Number 3 would be negative 3x.
All right, so this will be negative 3x.
Number 4.
Number 4?
Negative 6x.
All right, negative 6x. All right, number 5, somebody else?
Negative 5x, sir.
Negative 5x. And number 6?
Negative 5x.
Negative 5. Negative 5, you sure?
Sir, 5x.
Oh, 5.
Negative 5x.
No, it wouldn't be negative. You have negative 2x plus 7x. So remember, you take away the 2 from the 7 and the larger one. So larger one is positive. So the answer will be positive 5x. So for the positive, we don't really have to put any sign in front of it. So we can just write 5x. Question 7.
Negative 5a.
Negative 5a. All right.
Negative 5a.
Negative 5a. All right, so this is negative 5.
Yes, sir.
Question 8.
12m.
It says 12n. $12M. All right.
Yes, sir.
All right, 12M. Question 9.
5b squared.
5b squared. Question 10.
ab.
AB. All right, very good, guys. So everybody gets the hang of that. All right, moving along. We have more work. Here we have some more. So I'll give you about less than 5 minutes to do this. And just for clarification, question 14 goes all the way to minus 3z. So remember, this is one whole expression from here to here. And same thing for question 15. That's one whole expression. So please don't write them separately. They are just, they are single expressions. So simplify that. All right, anybody finish question 11?
Yes, sir.
All right, go ahead, what's the answer?
10x squared.
All right,
10x, sir. 10xy.
it says 10xy.
Yes, sir.
All right, let us see how you arrive at that. You sure, walk me through that, miss?
Sir, 14 plus 5 equal 19. And then I had the 2, that's 21. Sorry, 14 plus 5 equal 19. And then I have a negative 7. So a negative 7. So I would owe 7 from that 19, sir. So I would take away that from the 19, which would be, sir, this is not sure, sir.
That would be 12.
Yes, 12 would be the answer, sir.
And then remember the 2x that you have out here, so now.
Right, so it would be 14.
Right. So you in both cases that you did it, if you add 14 plus 5, you get 19 plus 2, 21 minus 7.
7, yes, sir. It would be 14.
So it's 14xy. All right. Anybody else with question 12?
Sir, negative
3x,
3x.
sir.
You said negative what, Miss Amanda? 3x?
Yes, sir.
Who else said negative 3x? I heard somebody else.
Me, sir. Wait some.
Yeah. All right, yeah. Now, if sometime if you look at the positive, so you have positive 7, you notice that if you add negative 5 with negative 2, you still get, it's going to give a negative 7. Negative 7 with positive 7 going to cancel out, and you have left negative 3x. Now, you can take different approaches to arrive at the same answer. But what you want to do is to try to find the easiest way to simplify, because time is of the essence when you are doing problems. All right. So you have to work against time. All right, everybody is good with that. Anybody for question 13?
Negative 6x squared, sir.
All right, so negative 6x squared. For 13. All right, so we have -4, -3, -7, -8, +2, -6x squared. All right, so -6x squared. All right, question 14. Anybody for question 14?
Sir, 7x minus 3y minus 6z.
All right, so let me write down your answer and then now find out if anybody else agrees with it. So you say what you have, Ms. Wilson?
7x minus 3y minus 6z.
7x minus 3y
Minus 6z.
minus 6z. All right, anybody else got the same answer? Let me see the answer, those who got that answer. All right. All right, walk us through this now, Miss Wilson. So for the x's, Miss Green, you want to walk us through it? All right, go ahead, Miss Wilson.
Mr. Green, sir.
Oh, you are the one who gave the answer, Miss Green.
Oh, sir, Miss Wilson gave the answer, sir.
Oh, so Miss Green, you want to walk us through it?
Yes, sir.
All right, go ahead. So we're going to first do
First, I group them.
the group the x's.
Group them.
All right. When the group goes now, what is the next? You add the positives and then take away the negative.
Yes, sir.
All right. It doesn't matter which way you want to do it. You could take away 2 from 3, then whatever you have, if you add it to 6. Or you could add 3 plus 6, you get 9, and then take away 2, you get 7. All right. So next, what you do next, Miss?
Group the Y's, sir.